All right, back at it as promised. Some more examples of balancing chemical reactions. All right, here we go. This is a great example of we're going to save hydrogen for the end. Okay, it's also nice to look at it because we've got, uh, I don't know what I was going to say. Oh, because hydrogen's all over the place. We also have a diatomic in here. So we're going to save hydrogen for the end, which isn't going to last super long. We have one calcium and one calcium, so we're good. Saving hydrogen. There's oxygen. There's one. There's two I don't know what that was. Two oxygens here. So we're gonna need two waters over there. Okay. And that's everything. Then we're gonna count hydrogens. There's two hydrogens. There's two hydrogens. There's four hydrogens, and ta-da, that one's done. Okay. Let's take a stab at this one. Again, hydrogen's all over the place. Hydrogen is kind of a slut that way. It's all right. Um, no judgment, just they're all over the place. Um, all right, but same idea. Phosphorus, phosphorus, we're good. We got five chlorines, one chlorine, so we need a five here. Okay, that leaves us with hydrogens. What do we got? We got three. Actually, we could do the oxygens. I forgot about those. Let's do those. That'll be easier. Four oxygens here, one there, so we need a four there. Now we can check the hydrogens. This side, reactant side, has eight. Does this equal three hydrogens and five hydrogens? Yes, that is awesome. It worked. Fantastic. All right. Here's another big one. Can we do it? Can we remember all of our weird little tricks we were doing? Let's see. All right. We're going to start where we have the most subscripts. Okay. So that's going to be the ammonium sulfate over here. Um, we have a sulfate. Do we have a sulfate on the other side? We do. So we can balance the sulfate as sulfate. There's one each, so we don't have to think about it too terribly much. Um, what else we got? We got ammonia. I'm hearing weird noises. I'm sorry. We have ammonia. We have ammonium over here. We have ammonia. Let's see. So this is essentially two nitrogens, so we want two there. I'm going to save hydrogen for the end. We'll skip over and do sodium. One sodium, two sodium, so we want two here. This gives us two oxygens, so we'll put a two there. Okay, then we should be done. Remember, we did the sulfate oxygens already. We're going to count our hydrogens and see how we did. 2 times 4 is 8 hydrogens. 2 times 1 is 2 hydrogens. Does this equal 2 times 3 is 6 hydrogens? 2 times 2 is 4 hydrogens, and that's no hydrogens. 8 plus 2 is 10, and that equals 10, so we're good. Okay. Sorry, I feel like I'm going a little fast, but come back, pause it, think through it, ask questions as needed. Okay. Um, last one in this set, I have another sentence for us. Remember, we need to practice our nomenclature as we go. Let's take a stab at this. Just break it down, read our way through it, and we're going to turn all this into a nice chemical equation and then balance it. All right. What do we got? An aqueous solution. That's good to know. That means we're going to have to label things as aqueous. Let's not be a pig here. Aqueous. All right. Ammonium chloride. So that's NH4Cl, and it's aqueous, so we can do that. And barium hydroxide. So we can assume ammonium chloride and barium hydroxide is both aqueous because it was together in solution. Remember, barium is a 2 plus and hydroxide is 1 minus, so we need two hydroxides to balance that out. And we put an aqueous there. Is heated. Oh, there's our verb and there's our heat. And the compounds react to give. Okay. Ammonia gas. Ammonia is NH3 and it's a gas here, so we put G. Okay. Barium chloride in solution. I'm running out of room. I'm going to list them down here instead. Barium is 2 plus, Cl is 1 minus. That's in solution. And water, so that's an H2O. We can assume liquid. I'm going to need to pause right here for a second. I'll be back. Alrighty. Sorry about that. We're back. Um, okay, so we've got our equation. Let's balance this dude as much as we can here. Um, and just dive right into it. There's really, at this point, we know what we're doing, right? Hydrogen is all over the place, so we're going to save him for the end. Okay. Just start at the beginning and work our way through. Let's take a stab at chloride. There's 2 here, so we want 2 here. Okay. That gives us 2 nitrogen over here, so we're going to put a 2 there. Okay. 1 barium, 1 barium, 2 oxygens, so we want 2 here. Okay. That's everybody except hydrogen, so count our hydrogens and cross our fingers. That's 8 hydrogens. This is 2 hydrogens. That's 6 hydrogens. And that's 4 hydrogens. So we're good. That's done. All right. Uh, hopefully, this is again one of those things we just want to practice. I know I make it seem like it's easy and I'm going really fast, but watch it again, go through it. We're counting atoms on both sides. Okay, we're going to get practice on this in class as well. So let me know how it's going. Don't forget our secret word for this is sterling, and I'll catch up with you later. Bye.